Hello everyone, welcome back to MAC 1140. So today we're going to do section 7.6, and this is the last section talking about matrix before we jump to another branch of mathematics. So in previous section we learned how to solve system of linear equation using row operation, the echelon form, and we know how to solve system by using the Cramer rules. Today we gonna talk about another method of solving system of linear equation. We will be solving the system by using another concept, by using inverse of the matrix. Okay, so let's start our section today. Section 7.6, inverse of matrix. Okay. Before we jump to how to solve system of linear equation by using matrix inverse, on first part of our lecture, I want to talk about definition of inverse. Matrix. We need to know what the inverse matrix means. You know, maybe you guys learn in college, or maybe you guys know what the inverse function already, right? The inverse function this is respect over the line y equal x. Of course, this is the matrix is not a function. However, there's some concepts kind of the same. For example, you know, back in the day we learned how to check if the two functions are inverse of each other. If we know that we compose f to g function and we compose g to f function, and both of them will turn out to be x, then we know that they are they inverse of each other. I'm sorry, I have very bad allergy recently. And we also know that if a function f have inverse, and the notation for the inverse function is f to negative 1, then f of f to negative 1 equal x, and f to negative 1 of f equal x. So we compose two functions equal to x, and x is identity function. Now let's get back to our matrix. When we talk about matrix, those concepts similar to the one we already learned in function. It means what? It means that the notation for inverse of matrix will be a to the negative 1. Okay, so if we have matrix A, given matrix A, then the inverse, then its inverse will have notation is a to the negative 1. Okay, so this is an inverse matrix of A. Of course, the inverse matrix is a matrix itself. It's a matrix itself. Okay, and because the matrix will hold in the same way as the function. It means what? If we have inverse matrix a to negative 1, and we multiply a to a negative 1, then this is equal to a to negative 1 times a. And instead of giving you x, which is identity function, it gives you an I. And what is I? I, we call it identity matrix. Now, what is identity matrix? So this is what identity matrix look like. It will have 1 diagonally, okay, and 0 for everything else. 0 for everything else. Okay, so it's one diagonally. Okay, so this is identity matrix. I can give you example of identity matrix 2 by 2, which is like this: 1 1 0 0. Okay. We also have another definition. I mean, most of the time we use that in linear algebra, but I just want to introduce that over here also. If matrix B is inverse of matrix A, then B times A equal A times B equal identity matrix. You know, back in the last time in the previous session, we learned that we don't have commutative property for matrix. If we have matrix A times matrix B, it's different from matrix B times matrix A. But in this case, I said it equal to each other if the product of these two matrices here, if they are inverse of each other, and the product of these two matrices here equal to identity matrix. Okay, then the commutative property holds. Okay, so B times A equal to A times B and equal to I. It must be equal to I, identity matrix. Okay, then we know that then okay, I already said that if matrix B is the inverse matrix, then B times A equal to B times A equal to A times B equal I, and vice versa. What does it mean by that? What I mean is that if we have matrix A times matrix B equal to matrix B times matrix A, and it equal to I, okay, then they are inverse of each other. Okay, sometimes we call them multiplicative inverse. So they are inverse of each other. Okay, then I can say that B is a inverse, is a matrix, inverse matrix of A. Okay, okay. So this is the condition. This is the only condition when in order to check if two matrices are inverse of each other. Okay. Remark. There's some important I want you to know. In order to have for the matrix to have inverse, in order for a matrix to have inverse, the condition is that that matrix must be a square matrix in order to have inverse. Okay, in order to have inverse, it means what? It means that if you have 2 by 3 matrix, then that doesn't have inverse, or 3 by 1 doesn't have inverse, or 3 by 2 doesn't have inverse. It must be a square matrix, and the definition of square matrix we already learned in previous section. However, not all square matrix have inverse. Second step, not all square matrix has inverse. Not all of them, but the condition for it to have inverse, it must be a square. But not all square matrix have inverse. The third one I want you to know: all identity matrix, okay, is square matrix, and always have inverse. It means what? It means all identity matrix is inverse. Okay, always have inverse. Okay, I can say that if I times I to negative 1 equal to I to negative 1 times I, then equal to I. Okay. Alright. Let's see what else. What do I want you to know? So I think this is a very three important things I want you to know when we talk about when we learn matrix. Okay. In the example, I will show you how to find a matrix inverse of the matrix. Given a matrix, and I asked you to find the inverse of that matrix, like last time in college algebra. You know, given a function, I asked you to find inverse of that function. Okay. Then when we talk about matrix, you know, we can find the inverse of that matrix. Of course, some of the square matrix doesn't have inverse, but we have to check. Okay. I'm not really sure there's a fast way to check if the square matrix has an inverse or not. I think there's a way. You can look it up online, but I don't think it's belong to the to this course. But I think there's a way to check if a square matrix has inverse or not. The way we do it now, because the way we do it now in the example is just we try to find the inverse of that matrix, even though we don't know they had an inverse or not. We just try to find it. Okay. So let's jump to the first example. Okay. First of all, so in this example, I want you to find inverse of 2 by 2 matrix. For 2 by 2 is very easy because we have formula. So given matrix A, and this matrix has had entry A, B, C, D. Okay, entry A, B, C, D, and then inverse of A will be 1 over AD minus BC times D minus B A minus C. So basically you just we just put the sign over here, negative sign for B and C, and we switch position for the for this diagonal D and A. Okay, so this is a formula. Okay, then we can find the matrix of 2 by 2, inverse of matrix 2 by 2 easily. Okay, what if I have A equal to 4, 5, 2, 3. Excuse me. Okay, and I want to find inverse of matrix A, which is A to negative 1. Will be what? Will be A to negative 1 over 12 minus 10 times, to keep the minus 5, negative 2, switch position 3, 4. Okay. Then give you 1 over 2, 3, negative 5, negative 2 times 4. Then I can distribute 1/2 into the matrix, the scalar property, remember. So give you 3 over 2, negative 5 over 2, negative 1, 2. Then you see that I successfully get the inverse of matrix A. Then the inverse of matrix A is another matrix, and this is what it is: 3 over 2, negative 5 over 2, negative 1, and 2. Okay, so this is this matrix, the inverse of matrix A. Okay, but that is when you are dealing with 2 by 2. What if I have more than 2 column and 3 and 2 for 3 by 3, we have to use row operation. Okay, we have to use row operation. So how are we gonna use row operation here? What if I have matrix A like this? And this matrix A is 3 by 3, so we have 1, -2, -4, 2, -3, -6, -3, 6, and 15. Okay. So this is 3 by 3. Of course, this we might have inverse. We might have inverse. Okay. Not all the time, but not all the time. But I mean, we had to find. We had to find out if this way matrix has an inverse or not. Okay. Most of the time they do, but not all the time. Okay. But the condition is 3 by 3, so it might have inverse. All right. So in order to find inverse of this matrix, let me get more paper. Okay. This is how you're gonna set up. You're gonna set up the 1, -2, -4, 2, -3, -6, -3, 6, 15, and you draw the vertical line like this. Okay. And on the right hand side of the matrix, you will write the identity matrix. So the identity matrix for 3 by 3, which is 1, 1, 1. Okay, 0, 0, 0, 0, 0, 0. So this is identity matrix for matrix 3 by 3. Okay. So our goal is this. Our goal is to use a row operation to convert this original matrix to identity matrix. Okay, we're gonna apply row operation on everything here to convert the original matrix to identity matrix. Then automatically what you have left on the right hand side will be the inverse of A. Okay, so right now what we're gonna do, we're gonna convert this to identity matrix. Okay, we're gonna convert this to identity matrix. It means that we need to have 1, 1, 1 here, and 0, 0, 0, 0, 0, 0 here. Okay, so how we're gonna do? We're gonna apply row operation. So this is what I'm gonna do. Let's see. I think I want to have 0 right here, right? Because of 1 over here, so I want to have 0 right here. So I'm gonna want to change R2. So R2 minus 2R1 give you R2, right? Okay, then I also want to change 0 over here, so we can do both of them at the same time. So it will be R3 plus 3R1 will be R3. So what we're gonna have, we're gonna apply our operation for everything. Okay, so R2 minus 2R, so give you 1. This is not changing. Okay. Okay, so this is not changing either. So R2 minus 2R1, 2 over 2 should be 0, right? The R1, 2 times -4, -3 plus 4, 1. It was good because I can convert it to 1. Okay, Negative 2 times negative 4, 8. Negative 6, 2. Right. R2 minus 2 is will give you negative 2. R2 1 minus 2 times 0 is 1. This is give you 0, right? Now we're gonna do for row 3. Row 3 plus 3 row 1, 3 times will be 0. 3 plus 3 times negative 6, so this is give you 0. 3 times negative 4, negative 12. 15 minus 12 give you 3. Okay, give you 1. 3 times it will be 3, right? Okay, 0 times 3 versus 0 is 0. 0 times 3 plus 1 is 1. Okay, so I already got 0, 0, 0 here, which is good. Now I want to have this 1, so I just divide R3 by 3. So I will have 1, negative 2, negative 4, 0, 1, 2, 0, 0, 1, 1, 0, 0, negative 2, 1, 0, give you 1, right? Divided by 3, 0, 1 over 3. Okay. Good. Right now our goal, it looks like we have diagonal 1 over, so our goal is to get 0 here. 0 here, 0 here. Okay, we try to get 0 all of them over here. So what we do? We're gonna do 0 here, so we're gonna change R1, right? So it will be R1 plus 2R2 give you R1. So it will be what? It will be 2R2, 0 to 2 times 0, so it will be 1. Negative 2 plus negative 2 plus 2 will be negative 4. Negative 4. No. Positive times 1, I'm sorry. Positive 2 will be 0, right? Positive 2 times 2 is 4. 4 minus 4 gives you 0. So 0, 1, 2, 0, 0, 1. This is not changing. Okay, we want to change our 1 only. So this is give you negative 2 times negative 2 times 4. So give you negative 3. 2 times R1. 2 times 2 should be 2, right? 0 should be 0. Alright. So we almost got it. We almost got it. Right now our goal is to get 0 here. Okay, easily. So we're going to change R2 minus 2R3 give you 2. Okay. So 1, 0, 0, 0, 0, 1. This is not changing. Negative 3, 2, because we want to change row 2. 1, 0, 1 third. This is R3, 0, right? R3, 0. So give you 1. 1 times negative 2 is negative. 1 times negative 2, negative 2. 2, negative 2, 0. Here you go. So 1, right? 1 times negative 2 is negative 2, so give you negative 4. 0 will be 1. 1, 3, negative 2 over 3, so negative 2 over 3. Alright, so look at that. I successfully convert the left-made original matrix to the identity matrix. Then what you have left on the right hand side here will be the inverse of A. Then inverse of A will be negative 3, 2, 0, negative 4, 1. Alright, so that's the inverse of matrix A. Okay, so you see that for 3 by 3, we don't have a formula. Actually, they might have a formula, I forgot, but if you look it up, there's a formula. But I mean, all the tests I will ask you to do row operation to find inverse of the matrix. So this, you see that this 3 by 3 has an inverse. Okay, and you do similarly for 4x4. You want to convert it to diagonal matrix, identity matrix, to be 1 1 1 1. Okay, for 4x4 will be 1 1 1 1, and originally you will set up 1 1 1 1. Okay, and you convert over here to the original matrix to diagonal to identity matrix 4x4, 1 1 1 1. Okay, and you can do the same for everything. Okay. Alright, let's say we have I'll give you an example. I will give you the example when a matrix, when a square matrix, it doesn't have inverse. Okay. Let's jump to another example. Example 3. Okay, and I give you the matrix like this. Let's call this matrix is matrix B, and this matrix is 3 by 3 also. Okay. Okay, and you see, most of the time you know this is a square matrix, so you will know that it may or may not have inverse, even though it's square matrix, but it may not have inverse. So we need to find out if this one has inverse or not. And the only way we learn in this course is to use a row operation. So we're gonna set up with the identity matrix 1 0 0 0 1 0 0 0 1. There you go, with the identity matrix. Now our goal is, again, we're going to convert this to diagonal matrix, and what do you have left on the right hand side will be the inverse. Okay, so what we do, you see the bottom over here, the last row and the second row over here, the first entry is 1 already, so I think it'd be good if I switch the position of route 2 and route 1. So route 1, route 2, we switch the position so that you have 1 on the top, 1 2 7, 2 negative 3 negative 7, 1 1 4 still there, 1 0 0 0 1 0 0 0 1. Okay, so right now our goal is to get 0 over here, right, and to get 1 over here. Okay, you want to get 0 over here. So we go with it, and we want to get 0 over here also, 0 and 0 here and here. Okay, so we're gonna do, because we want to change R2 minus 2 R1 is R2, and we want to change, so be R3 or R3 minus R1 could be R3. Then my new matrix could be first row, I'm keeping that. Okay, negative 2 times 2, negative 2 times 1, so negative 2 times 1 is, so 0, negative 2 times 2, negative 4, and negative 4, so this is giving you negative 7, right? So we need 14, so give you 14, no, negative 14 minus 7 give you negative 21, right? Same thing over here. 1 negative 2, right? 1 time, oh, we want to change, so it will be negative 2 R1 to negative 2, right? Negative 2 times 1 is negative 2. Oh, I forgot because I switched R1 and R2, I forgot to switch this, so I'm sorry. So I will have to switch this, so become 1 0 0 and 0 1 0. Because every time you apply the row operation, you have to change this too. So it will be 1 0 0 0 1 1. So it will be negative 2r1. So give you 1. Right. Then this is negative 2, right? And this is 0. Okay. Now we do for the last row 0, right? Negative 1, negative 3, 0, negative 1, 1. Okay. So that's the, so we already got 0 0 here. So our job right now is to get 1 right here. So I divide row 2 by negative 7. Alright. Then our matrix will become 1 2 7. 0 1 0 0 1 3, negative 1 over 7, negative 2, positive 2 over 7, 0, right? Okay, so right now we have 0, negative 1, negative 3, 0, negative 1, 1. Okay. Now we want to get 0 right here, right? So we want to change R3, add to R2 will be R3. We're going to use R2, so it'll become 1 2 7 0 1 3. I'm not changing that. 0 1 0, negative 1 over 7, 2 over 7, 0. Add them up, so we'll be 0 0 0, negative 1 over 7, negative 1 over 7, right? Add them up, so 2 over 7 minus 1, so negative 5 over 7, 1. Okay, so what we get after I change this to 0, okay, after I change this to 0, what I have is that this is also 0. This is also 0. And look at that. If this is also 0, there's no way we can bring this to 1. Because our goal is to get 1 over here and 0 0 0 here. But this right over here I got 0. The diagonal is 0. It has 0 inside. So there's no way we can convert this to identity matrix. You see? Then, so because of this, then matrix B does not have inverse, even though it's a square. Even though it's a square. Okay. Good. So this two, the example over here is showing you that even the square matrix, it doesn't have inverse. Okay. And if you have time, look it up. You can know right away if the inverse has a matrix or not. Okay. Well, I mean, you can use calculator to check if the inverse has matrix or not. But if it does, please, you have to show work. Okay, on the test, you have to show work like this. Okay. And if it have inverse, you also have to show work. If it doesn't have inverse, you also have to show work, because this is the evidence showing that this matrix B right here doesn't have inverse. Okay. So on the second, so after you know what inverse matrix is already, on the second part of the matrix of this lecture, I want to show you how to solve system of linear equation using inverse. Okay. Actually, that's it's easier than row reduced echelon form. They're all reduced echelon form. That's better way. It's I think this is the better way to solve system of linear equation, because you just need to find inverse. Well, I mean, it would take time in order to find the inverse, but if you have calculator, it's very fast. Okay, solving system of linear equation with inverse. In a previous section, I already introduced the general form of matrix equation already, right? I wrote something like this, right? A11, A12, A1n, and this an1, ann, and over here I use x1, xn. You know, instead of using x, y, z, but we just think that we have n variable, then we cannot use x, y, z, because we have limiting number of letters. So I will use x1 to xn, and over here we have b1 to bn. Okay, so this is a matrix equation. Okay, this is a matrix equation. Let's call this matrix is matrix A. Okay, and over here is color matrix. I call it matrix X. Okay, and over here I call this matrix matrix B. Okay, so if we have a system like this, a system of linear equation like that, okay, from here we can get a system easily, right? We already learned last time. Then I can rewrite this as matrix A times matrix X equal matrix B. Our goal is to get X. Okay, our goal is to get x1 to xn. It means our goal is to get all the entry for the matrix X. Okay, in order to do that, we're gonna use inverse. Okay, we're gonna use inverse of matrix A. Okay, we're gonna use inverse of matrix A. So what we're gonna do is we're gonna multiply both sides by the inverse of matrix A. Okay, so I multiply matrix A by the inverse of that. Okay, then you see that A to the -1 times A is equal to identity matrix, equal to I, right? So I times X is X. Then matrix X will be A to -1 matrix of times B. Okay, so in order to solve the system, you just need to find the inverse of matrix coefficient here, coefficient matrix here, because all the entry over here you get it from the coefficient of the system. Then you find the inverse of that. Then you multiply by B. Okay, multiply by matrix B. And you see that because A is a square matrix, of course, but you see that it's not always have inverse. So sometimes we don't have solution for the system. Okay, sometimes we don't have a solution for the system. Okay, but in order to find the inverse, the system, you just need to find the inverse of the coefficient matrix. Okay, so let me name this as let's call this coefficient matrix, because all the entries for this matrix is come from the system. It's the coefficient of the system. Okay. Let me give you an example, a quick example of 2x2 system linear equation, two variable. Example 1. Okay. We have a system like this: 2x minus 5y equal 15. So this is two variable. 3x minus 6y equals 36. So first of all, from the coefficient and all the number, I can get the matrix equation. So it will be 2, negative 5, 3, negative 6. Instead of using x1, xn, we have enough variable here, so we have x and y. We have column matrix is 15, 36. So in order, based on the concept, the formula, so in order to find x and y, you just need to find the inverse of coefficient matrix. Okay, just find inverse of this. All right. So this is, I call matrix A, right? And then I want to find inverse of that. So we have the formula for 2 by 2. So 1 over 2 times negative 6 minus 3 times negative 5. Right? Multiply by 5, negative 3, negative 6, and 2. Okay. Then give you what? Give you 1 over negative 12, 15, give you 3, negative 6, 5, negative 3, 2. Distribute them in, so give you negative. You know what? I think I'm gonna leave it like that, because if I distribute, give you the entries fraction, so I don't want to deal with a matrix whose fraction, whose entries are fraction. So I'm gonna just leave it like that. So that's the inverse matrix of A. Okay, but in order to get X matrix, I mean the big X right here, which contain X and Y as the entry. So matrix X will be the X and Y. So X and Y matrix. You take the inverse, right? You multiply by B. See that? You take the inverse, you multiply by B. So take the inverse. So 1 over 3, negative 6, 5, negative 3, 2. You multiply by matrix B, which is the last column matrix right here, which is 15 and 36. Okay, so this is your B matrix. Okay, this is B matrix. Okay, all right. Then now we multiply by 2 by 1, 2 row 1 column. So you see this and this is the same. We did learn how to multiply matrix already. Then the answer will be 2 by 1. Right here, the answer will be 2 by 1. Then you multiply by 1/3 also afterward. Alright. Row time column, row time column, row time column, row time column. Okay. It's take a little bit time to do this. So negative 6, 15, plus 5, 36, right? And row time column, so negative 3, 15, plus 2 times 36. Okay, so you have is 1 over 3. Calculate amount. So negative is negative 90, right? 5 times 36. 5 times 36 minus 90 is 90. Okay. 3 times 15, 45. 2 times 36, 72 minus 45 is 27. Okay. Then don't forget, multiply by 3, so we give you 30 and 9. Right. Then your X equal 30, Y equal 9. Okay, X could be corresponding to 30 and Y be corresponding to 9. Here you go. So you got x and y. Alright. So you see that as long you can find the inverse of the coefficient matrix, then you can solve the system easily. Okay. You do the same for 3 by 3. Okay, if you have 3 variable, 3 by 3, then you can set up 3 by 3 matrix. Because you have 3 variable, then you can find the inverse of 3 by 3 matrix. Then you multiply by the column matrix. Okay, then you get x, y, and z easily. Okay. Of course, because for 3 by 3, you know, we don't have the formulas. Then in order to find the inverse, you have to do on scratch paper. Okay, you have to do on scratch paper. But I mean, it's going to be you also have to use this concept. Okay, make sure that you take that inverse multiplied by b, then it gives you another matrix, which is the matrix X, which is XYZ or XYZ S or something. It depends on how many variables in your system. Okay. Alright, so for this one, I just give you one example. I think it's enough for you to understand the concept already. If you want me to go through another example, I will go through later, but I think that's enough. Okay, I think that's enough, because for 3 by 3 you do the same. You do the same. Okay, of course for 3 by 3 you don't have to, you don't use the formula. You have to find the inverse of matrix 3 by 3 using row operation. Okay, so I think I'm gonna stop our lecture right over here, and we stop the whole section, the whole chapter 6 right here. Next time we'll be jumped into chapter 7. We'll be learning a new concept, a new math concept. Is the we call that conic section, or sometimes we call that analytic geometry. When we analyze conic section, actually it belongs to analytic geometry. Okay, I'll see you next time. Bye bye.